Throughout this video, you will see some of the same methods used for each of the examples. Some of these will be, we will have, let's just say, let's add number, some type of signs. You'll have X, another sign, and another number. And X could even have a number right here, blah, blah, blah. And you'll always see me trying to figure out ways how to get X by itself with numbers on the side, or X by itself with a 0 on the side. And these are important to understanding and solving inequalities. So keep this in mind as you watch the video. For our first equation, we must solve -8 is less than X and X is less than or equal to -2. To help us solve it, we will break it down into smaller equations that hold the same meaning, such as -8 is less than X, and then X is less than or equal to -2. Breaking it down like this allows us to visualize it on a line graph. And we'll have 0 right here, since these are negatives, and the least most value, which is -8. We know that -2 is going to be our another value, and it's closer to 0, so we'll just pull out it right here. We know that -8 is less than X, or otherwise known as X is greater than -8, but that can just be something else you write down if you need to. So we know that X is going to be greater than -8, so it's going to be values of -7, -6, and so on. However, we have another condition where X is less than or equal to -2. So we can do the same thing and show all the values that are less than -2. Because of this overlay, we can simply go to these lines and cut off unnecessary arrows, since we know that X will now be between these values. Since X will be between these values, we understand that X will not generally equal 8, but it will be around in the vicinity. So that's why we add parentheses to show a type of uncertainty. We know that X can be -2, or it can just be less than. So we'll put brackets to show that has some certainty to that. Now when you write an interval notation, you put the least most value that you're given, which is -8, and the greatest value you're given, which is -2. And -8 is not included or kind of uncertain, so we put parentheses, and -2 is included since it has the greater than sign, and this is what it looks like in interval notation. This interval notation just allows us to understand what the possible values of X can be. It should be noted that question 1 has properties that apply to the rest of the examples. So let's find some similarities. For question number 2, we have -4x plus 3 is less than or equal to 23. Usually, you want to have X by itself. So the way to do this is simply simplify. -3 minus 3, and you get -4x is less than or equal to 20. Next up, to get X by itself, we divide by -4. And as you know, if you divide by a negative, actually, let's just write an equation, you have to flip the sign. And we're left with X is equal to -5. We're not done yet because we still need to write it in interval notation. Oh, that's nice spell notation. Okay. So we know that X is greater than -5. And since it also has this sign, we know that -5 will be included, and it's also our least value. To help you visualize better, you can also have it on a line graph if you need to, but I consider it unnecessary. So here we have our least value, and we need all the values that are greater than -5, since they could be X. This arrow will continue on into infinity, so then you just write down infinity. Automatically, infinity is a kind of an undecisive or uncertain number, so we'll put parentheses. For question number 3, we have 5x plus 3 over -2 is less than or equal to 6x plus 2. In our previous example, we did not have a fraction, and yet we were still able to simplify and get X by itself. So how can we simplify this? First, we must cancel out -2 by multiplying it by -2. What do I mean by this? Well, we have -2 times 5x or plus 3 over -2. And what we do to one side, we must do to the other. And with that, the x's cancel, but we are multiplying by a negative, so you must flip the sign. Then we simplify, we get negative 12x minus 4, and we need to get x by itself, so we'll do minus 3 plus 12x plus 12x, and we get 17x is less than or equal to, what is this, negative 7. Now we need still to get x by itself, and we're left with x is less than or equal to negative 7 over 17. But wait, we still need to write this in interval notation. So let me use my shirt to set this up. I also have an eraser, but it's too little. So we know that x will be greater than our least value. So we put the least value first. And any value that is greater than this is essentially infinity or positive infinity. And we have our greater sign, so we know it's included since x could equal it. But it's uncertain if x could equal infinity because it's infinity, and infinity has some weird properties. But this is our answer in interval notation. In our previous examples, we had x on the other side or on both sides. This time it is in the middle of two other equations. So the best thing to do is to simplify, but this time instead of simplifying from one side to another, you have to do it to both sides. So this is how it will look like. We need to cancel out our denominator of 2, so we'll multiply it by 2. And then what you do to one side, you must do to the other. These cancel out, and you're left with negative 4 is less than or equal to 2x plus 8, which is also less than or equal to 26. Next up, it is best to subtract 8, and what you do from one side, you must do to the other. And you get negative 12 is less than or equal to 2x, which is also less than or equal to, what is this, 18. Then you divide by 2, and you get negative 6 is less than or equal to x, which is now by itself, which is less than or equal to 9. So we have the values negative 6 and 9. Nice. But x is, let's see, so we know that negative 6 will be our least value, and negative 9 will be our greatest value. Both have the equal to, so we know x could possibly be these values, so we'll include them with brackets, and this is our interval notation. Our next example is different from the previous one since we are dealing with a quadratic inequality. And the only main difference is that factoring will be included. So how do we get to the factoring stage? Well, we have to switch from this side, or switch, put the 25 to the other side. So this will be 3x plus 10x minus 25 minus 25. And we are left with this. Make sure to include 0. It is quite helpful. So next up, how do we factor this quadratic? First of all, you can have the middle value separate or have a difference. So for example, let's see, it'd be plus 15x minus 5x, yes, minus 25 is less than or equal to 0. No matter what, these two will equal to 10x, but we separate the values to help us factor. So generally when factoring, you want to focus on two numbers at a time. So for example, we can forget about these for now and only focus on the 3x squared plus 15x. And the way you can factor it out is a 3x. Because we're taking an x from the x squared, which is just x times x, is just x. And then we add the plus 15 divided by 3, since we're taking out a 3, and we get just 5. And we also take an x from it, so it just stays as 3x, is multiplied by x plus 5. And if you needed help understanding this, you could just multiply it like this, and you should end up with the same value. And now wherever you get in parentheses, you want to also get it for the other side that you're factoring. So the way we do that is by factoring out -5, and this equals 2x. We're taking out a negative, so this becomes positive. Taking out 5, this just becomes 5 less than 0. And then you could use both of these and take them out, such as you do in a kind of square root situation. And these can become their own little term, 3x minus 5, less than or equal to 0. Now, to help us solve the solutions, we can change this only temporarily to an equal sign, and then we can separate it into different parts. Let me see here, here, and they both equal to 0. Then we do simple solving. This equals to -5. This becomes x equals 5/3. Then for interval notation, in case you haven't caught on, this is quite important. You have your least value, your greatest value, and you need to figure out if they're included or not, and it is. And since x are both sides or on one side, it will, or at least both values will be included, and that is for our interval notation. For question number 6, we have x minus 4 over x minus 6, which is less than or equal to 0. To solve this equation, you must recall a quick trick we did for number 5 is where we set both of these, or I guess both the parentheses equal to 0. And we could do the same thing, but instead of multiplying, we are dividing. And for this rule, the denominator will always be non-inclusive or just in parentheses. So then we can just continue as normal. And simply solve, we get x equals 4 and x equals 6. Now for interval notation, we must put the least value and then the greatest value that x can be. And since x minus 4 is a numerator and has the equal sign, we can write it as inclusive or a possibility that x could be. And x minus 6 is a denominator, so it automatically has to be in parentheses. And that's how you solve it for interval notation. For example number 7, we have 7 over x plus 3 is greater than or equal to 1 over x plus 3. Now to solve this, we must have 0 on one of the sides. So we can easily just rewrite the equation as the same, but we add it or subtract it to the other side. This cancels out and becomes 0. And now we have it the way we want to solve it. Since the denominators are the same value, we can actually combine these equations to form 7 minus 1 over x plus 3 is greater than or equal to 0. Simplifying this down to x plus 3 and this. And recall from example number 6 that this is inclusive and this will be non-inclusive. Since this value doesn't have an x, we don't really necessarily need it for our interval notation. So all we have is x plus 3. Reminder, it will be inclusive or uninclusive, whatever. Equal to 0, x equals, x equals -3. -3 will be our least value since, let's see, over here, I guess kind of right here, x will always be or greater than or equal to 0. So what are some values that are greater than 0? Infinity. And this is not inclusive, and automatically infinity is also not inclusive. That's how you solve it for interval notation.